Hello, my dear learners. Today we are going to learn a very interesting topic of physics. Students, you all must have observed that whenever you put your mobile phone in the charging point, right? And whenever you put your laptop in the charging point, the charger gets heated up. Have you ever wondered that what is the principle behind it? Why is it so? Why the charger is getting heated up when you put it for the longer time inside the switch? So let me tell you that there is a very famous principle behind it, that is the heating effect of electric current. Students, our today's topic will be the heating effect of electric current. We will delve deeper into this topic and will get to know about it, that why the charger is getting heated up, right? So let me write the heading that our today's topic is heating effect of electric current. Right? Now we are going to see that what is that principle, right? So this principle was given by the James Prescott Joule, and by which, due to which it is also known as the Joule's law of heating, right? It is also known as Joule's law of heating, as it was given by the scientist Joule, right? Now he stated that the amount of heat generated inside the any conductor will depend on the current flowing through the conductor, and it will also depend on the resistance, and it will also depend on the time for which the current is being flowing inside the conductor, right? So the statement given by him was, let's say the amount of heat that is generated inside the conductor is denoted by capital H, right? It is directly proportional to the current, to the square of the current, right? And he also stated that the heat generated will be also directly proportional to the resistance of that conductor, right? So here we have denoted resistance by capital R, and he also stated that heat will be also directly proportional, or it will depend on the time for which the current is being flowing inside the conductor, right? So by summarizing these all statements, all three statements, we can write here that at H is directly proportional to the I square R T, right? And to remove the proportionality sign, here we will take a, constant of proportionality, let's say K, that is I square R T, right? Here value of K will be 1, so this will become H is equals to I square R T, right? So this was the statement and the formula given by Joule's scientist, and he stated that the amount of heat generated inside any conductor when the current flows through that conductor will depend on the square of that current and the resistance of the conductor and the time for which the current is being flowing inside the conductor, right? Now we will derive this formula mathematically, right? So now you all must have studied about electric potential difference, right? So electric potential difference formula was V is equals to W by Q, right? We define electric potential difference as the amount of work done to move a unit positive charge, right? So the WV is potential difference, electric potential difference, Here W is the work done and the Q is the unit positive charge. Right? Now, by transposing this Q to another side, we can write this formula W is equals to VQ, right? And in your previous classes, you all must have studied about that Ohm's law. Ohm's law formula was V is equals to IR, right? V is equals to IR. It was by Ohm's law. Ohm's law. Now, so we will substitute the value of V inside this equation. In place of V, we can write IRQ. So now it becomes IRQ. Now, and you all must have studied that the current can be defined as I is equals to Q upon T, right? So, from here we can write Q is equals to IT by this formula, right? So now from here Q value will be substituted in this equation. So equation will become IR IT, right? Now we can write it, that is I square RT. So now here W will be written and this R formula has become I square RT. But here W is equals to I square RT, right? So work done is equals to the amount of heat generated, right? The amount of work done which is being done inside the conductor when the electrons drift through inside the conductor, they do some work, right? And that the amount of due to the amount of work done which is being done by the electrons, and inside the conductor when they drift, they do collision with the atoms of the conductor, right? And when they collide with the atoms of the conductor, they transfer their kinetic energy into the atoms, right? And as they are transferring their energy to the atoms of the conductor, so they are doing some when they are drifting, they are doing some work, right? When they are moving from higher from lower potential to higher potential, right? So electrons start drifting from lower potential to higher potential as our negative terminal is at lower potential and electrons are negatively charged, so they are repelled by the negative terminal, right? So I am going to explain by drawing that when we are having a thick wire conductor and when it is being connected with a battery, right? So now here it is our positive terminal and it is negative terminal, and our conventional current flows from positive terminal to negative terminal, right? Now as this is a thick wire conductor, right, of resistance R, right, and the current I is flowing through this conductor and the time t for which the current is flowing, right? So now as this is a thick wire conductor, so it must be having some free electrons, right? So here let's say draw these electrons. Now they are drifting from lower potential to higher potential, right? During their drift, they collide with the atoms of this conductor, this thick wire conductor. They collide with the atoms of this conductor, and when they collide, they transfer their kinetic energy to the atoms, right? And when the kinetic energy is being transferred to the atoms, then the atoms start vibrating, and due to which due to their vibration, the temperature of this conductor gets heated, means rises. The temperature gets rises, right? And due to which the heat is being generated inside this conductor. So as electrons are drifting, so they are doing some work. So I have told you initially that the potential difference is the amount of work done to move a unit charge, unit positive charge, or unit charge. We can take electrons as well, right? So here electrons are moving, so they are transferring their energy to the atoms, and then the atoms are starting vibrating, right? They are started vibrating, and so due to which the temperature is increasing inside the conductor, right? So as the heat is being generated, so here we can write W is equals to H, right? That amount of work done will be equals to the heat generated. So now here we can substitute this value. So H is equals to I square R T, right? So now our formula has become that H is equals to I square RT. This was the statement given by the James Prescott Joule. I hope this is clear. On this principle, there are various electrical appliances, right? You all must be using in your daily life. First one is the electric heater. Electric heater. On this same principle it works. Second is the electric kettle. Electric kettle. Third one is electric iron. Electric iron. Fourth is electric fuse, also works on this principle, right? So I hope electric fuse. So this was whole concept for today's class. Thank you all.